Hello, this is Automated Add-on Extension Testing. I'm Spencer Magnuson and I will be presenting. In this presentation, I will talk about scripting tests for your add-ons, so that way add-on development can be more maintainable and manageable. For context, I was supposed to present this at the Blender conference. I had it scheduled and everything, flights and everything, but I got sick with the norovirus just a couple days before my flight. And so while the slides are publicly available for a while now, I figured I should at least try to record myself presenting. So whether you're a power add-on developer that you just want to take your test to the next level, or if you're a beginning add-on developer and you just want your extensions to be more maintainable and scalable. So whichever you are, this presentation should have something for you. Now first, let me give a brief overview. Firstly, I'm going to go over the benefits and the why, kind of for all the business and project managers out there, of the why behind scripted tests makes such a big difference. Then I'm going to go over designing your tests. So what type of tests are most effective and most useful for your add-on development. And then I'm going to go over how to test with Blender, whether that be without the UI as well as with the UI, which is very exciting. I'm going to go over some general miscellaneous tips on how to make the testing workflow more manageable. I'm going to go over a code demo and example showcasing a lot of these elements with an add-on template that will be made available at the end, as well as Light Painter. But before I get into the benefits, have you ever, as an add-on developer, had to make a quick hotfix only to realize you were just reintroducing another bug in the process? I've definitely done that a few times, sadly. But have you ever also added a feature where you thought it was just a simple, straightforward feature, but ended up just changing over a dozen files and had to make such dramatic changes that you just knew it'd be a pain to review and test? Or you just knew that your code just needed a full rewrite, but you didn't want to do it and you didn't know if it would work. We've all had those moments where we just want to rewrite the entire repository, but because of the work that it takes and the amount of time that it takes just to review and test those changes, you just don't think it's even worth it to bother. Well, in those cases, what are our options? So firstly, you could make your add-on small. You could just keep your add-on small and just kind of mitigates a lot of these issues. Well, I'm a big fan of add-ons that are small. I prefer small add-ons over big add-ons, but some add-ons kind of need to be big. Some users need a big add-on to handle their workflow and all their use cases. And some add-ons just kind of are inherently big because of the types of tasks that they're doing. So ideally keep your add-on small, but sometimes practically that's just not an option. Well, in that case, who do we have to test our add-on? Well, we could have our users test it. We'd have a beta option for our add-on and just have the users test it. In some cases, this works really well, but there's always going to be the case where you're letting bugs let through that the users just don't appreciate, and users can kind of get burnt out over testing small bugs that should have been fixed before they even got to them. So it can help in some cases, but it doesn't solve everything. So if the users shouldn't test, should we just make ourselves test it? Well, we can, and if we had small add-ons, usually manually testing just takes about 5-10 minutes. That's maybe not always an issue, but when you're working with bigger add-ons, it can sometimes take a few hours or even an entire day to test an add-on, and that's including breaks and switching between different types of workflows and handling different types of files. Maybe your add-on works with different pieces of software, and so you have to work with that. And it can just lead to a lot of burnout, and I think there's a more sustainable way, and that's with automating those tests. So instead of manually testing things, you just have a script run those tests for you. And while it does require the same amount of setup as you would with a manual test, in the long run, it's much more maintainable and easier on both the developers and the users. I've been developing and testing add-ons over the past several years, and I've found that testing has always made a big difference in my add-on development. From even as early on as Shot Matcher, which is more compositing and visual effects, to something more mathematical like NView or even Proxy Plus. With Light Painter, when I added the tests, I wasn't sure exactly what to do with it because it's so UI focused and Blender testing is inherently without the UI, until recently with the UI tests, which I'm excited to show you. So for the product and project managers, what are the benefits of scripted testing? Why am I asking your add-on developers to add tests that takes time and money? Well, firstly, the big benefit is consistency, i.e. less human error in testing. As I said, with manual testing, there's always going to be the times where while you're testing, you just want to skip a test or maybe do it a little bit differently or take long breaks, which makes the testing take longer, and it's just not maintainable or consistent. But with scripted tests, you can take out a lot of that human error and time wasted by using the computer to test it for you. Next, and probably one of the big ones, is fast feedback. So story time with this one, that when Blender 4.4 came out, action slots were introduced for animations, which just makes animations a little more manageable, and you can manage multiple objects with animations at once. Very useful. However, a lot of animation add-ons broke. But whenever there's a new Blender version, there's always the moment where you're just like, what broke? What do I have to check? What do I have to fix? It can always be frustrating having to go in and check everything. Well, with scripted tests, you can quickly find out what breaks and what doesn't. In this case, with animation action slots, I ran the tests and was like, only the keyframe test broke. It must be the keyframes. And with tests comes error logs. So I'm able to quickly troubleshoot and triage of, this is the code that's failing, or this is the part of the test that it didn't meet. And so I can check and troubleshoot what went wrong. In this case, part of it did require a fix on Blender's side. Shout out to Cybran in Alaska for fixing that. But in this case, I was able to resolve this issue within a day because all I had to do was update to Blender 4.4, run the tests, and then triage from there. I didn't have to do any preliminary setup and installation just to get to the part of testing. It was a matter of just a few clicks. Next, higher quality code, i.e. less human error in the coding. Now, I'm a lone developer for my add-ons, so I am the human error in all my coding, but it's always important to have a quality standard, especially when you're working with multiple developers, or maybe you're transitioning between different developers at different times. And so being able to have a quality standard with your tests becomes a great equalizer. And scripted tests are a great way of being able to ensure that no matter who is working on your code, that quality standard is the same. Fourth is scalable. Now, scalable has an asterisk, and it's only if you maintain your tests. Now, story time, earlier this year, I was working on Seam Boost, which is an add-on that's not mine, but I was helping contribute to it. And I was making tests as I coded for a long time, and I was like, you know what, I don't need to make more tests. I can just focus on the coding for a while and get that done quicker. Well, after a while, I started noticing that bugs were being reintroduced, and things that I thought were fixed were no longer fixed. And I quickly realized I've been updating my tests, I've been adding more tests, and therefore the code is no longer as scalable as I thought it was. Tests do make your add-on code more scalable and maintainable, but only if you maintain your tests with it. So make sure you do that. Lastly, and most importantly, user satisfaction. I know reviews on SuperHive can be hard to come by, but I have had good reviews, and a lot of them have been around customer support. And a lot of that I credit to the fast feedback that I mentioned earlier, because I can go from reading the customer's message to pushing out a hotfix in less than an hour because I can code the fix and test it, and I have the confidence to know that my fix works and didn't break anything else, thanks to the scripted tests. So all these other benefits add up to a better developer experience and a faster experience, which also leads to a good user experience. Now, enough about the benefits. How do we actually design our tests? What types of tests are important to have to be useful? So let me go over kind of 5 important types of tests that I would make sure that your add-on tests always have. Firstly, installation. So when the user installs your add-on and enables it, that there's no issues. And little side rant, make sure that that actually happens quickly. I've had some add-ons where I try to click the checkbox and it takes like 10 seconds before it updates. That should be almost instantaneous. Don't have that be a slow thing. And something I'll point out is that add-ons and add-on extensions are handled differently. So for example, with add-on extensions, Blender will try to handle any included Python package wheels or other compiled code. Blender add-on extensions will also be handled differently based on permissions. And so in some cases, it's actually good to test both add-on extensions and add-ons as part of the installation. And I'll show how you can do both of those things. Eventually, most users will just be doing add-on extensions, but For the sake of backwards compatibility, I think it's worth just testing both. Second, accessing properties, make sure that your panels and operators are registered correctly and that everything's accessible. Third, operators. So all the buttons and menu items that your add-on has, make sure you test each of those. Usually what I do is I just make a test for each operator, and then with just minimal setup code, I just run the operator. Just don't do anything else, just test that. Now, of course, you can add more nuance to the tests as you go on, but initially, just make sure the operators run. Fourth, non-Blender packages. So this includes Python libraries or executables. Maybe you have FFmpeg included with your add-on, or motion tracking or unwrapping binaries, something like that. But a story for this one, when I was working on the Scene Boost add-on, I was working with OpenColor.io because I was doing some image conversion, and I noticed that online, all the examples weren't working. They would copy and paste the examples from Stack Overflow or other sites, and they just didn't work. And of course, AI was no help because that was just pulling it from Stack Overflow. And I didn't know what the cause was. After I looked into the official OpenColor.io documentation, I realized the issue. OpenColor.io had a major update recently, and it entirely changed its workflow of how the code worked. Functions were named differently. And so all the examples online and AI were wrong. But it's an important thing of whenever you need to update these executables or libraries, you need to make sure your add-on can still interact with them correctly. And sometimes this will be inherently tested as just running the operators, for instance. But these are good things to test specifically for, so whenever you need to update those libraries or executables, that your add-on can still work with it correctly. And lastly, don't forget uninstallation. Just because the user unchecked your add-on and uninstalled it, and Blender closed, doesn't mean there's no errors. I've actually seen some add-ons just as Blender is closing, you just see this brief error of, oh, the add-on failed, but because Blender closed, no one sees it. But those are still important. Make sure that your add-on can be uninstalled without a trace or errors. So those are the main types of tests. Let me go over a few other types of tests that are good to have as you continue maintaining and updating your tests. Firstly, bugs. If you have a bug that you just never want to see again, add a test for it that tries to reproduce it and ensure that the bug never comes up again. So this fun example is that for my code editor, PyCharm, it would automatically add absolute imports of NView at the tops of files sometimes. The problem is with Blender add-ons, Blender discourages absolute imports of add-ons. It tries to encourage relative imports. And so what I did to prevent that is I literally just had a test read the files and say, if there's an absolute import of NView, fail the tests. Next is input validation. As I said with operators, operators often have different parameters and properties, so it's good to test all the different modes and settings that your operator has. And that can be even settings and parameters based on the context. So in this case, with NView, it relies on a camera existing in the scene. And so if there's no camera, it should throw an error. And so with this test, I just delete the camera and make sure that all my operators throw errors as they should. Next is load and performance testing. I know load testing and performance testing are different things. I was trying to save some room on the slide. But load testing is when you're testing a large load of data on your code. For example, if you have a motion tracking add-on, for instance, maybe your test loads a large video file to do the tracking on. Make sure your add-on can handle large video files. Or if it's performance testing, making sure that the operators run in a reasonable amount of time. So in this case, with NView, there's a raycast option, and I want to make sure that it doesn't take a ridiculous amount of time on a simple scene. All right, we've talked about tests for a while. What about testing with Blender? How do we test with Blender? So the main one that I would recommend is Blender as a Python module. And so if you have the source code, you can actually just build it directly with make BPY. But if you don't have the source code lying around, you can just download it as a release from pypy.org or use pip install. It's pretty straightforward. It runs just like if you ran Blender without the UI. It runs practically the same and can do your tests. This works well if you have a Python environment already set up. But if you don't, you can just use the Blender executable itself, because Blender already has a Python environment built in. So you can just run the Blender executable, run it in the background without the UI, give it your Python test file to run, and ideally factory startup, just that way it's not bringing in non-default add-ons or settings. With those two things, you can pick whatever testing framework you want from Python. The two that I would recommend is Unit Test and PyTest. Unit Test is built into Python, so you don't need to do any more installs. So this is great if you're using the Blender executable option. You can just use Unit Test built into Python, works right out of the box. If you have a Python environment, I would recommend PyTest. It has a lot more extra features, which I'll go over one of them in a moment, and it gives a lot more flexibility. With those testing options, that's just testing Blender without the UI. But how do we test Blender with the UI? Because many add-ons require modals or other UI-based operations, and it would be good to be able to test that in some way, right? Now, if you asked me 6 months ago if testing Blender's UI with a script is possible, I probably would have just said no. But just recently, in preparation for this presentation, I learned of a feature with Blender that allows this to be possible, and that is event simulation. It's just an extra flag in the command line, so I don't know if this is possible with the Blender Python module. I'd love to be able to figure that out if that's the case. It allows the code to simulate user events, whether that be clicking a mouse button, moving the mouse, or pressing a key. And I'll go over this in my demo. So now that we know how to test in Blender, I'll give a few miscellaneous tips on improving that testing workflow, and then go over the demo. Firstly, don't be afraid to use blend files. It's nice to be able to recreate tests with just Python code, but sometimes in complex cases, it's easier to just use a blend file. In this case, I had a test file constant where I just had a path to a test blend file, and I just opened it. And I had this in my fixture, so that way I didn't have to run this over and over again, which is the next thing that I'd recommend. With PyTest, you can use fixtures to run code for each of your tests without having to rewrite that every time. So for example, there's the context, ops, and calling method functions here, each annotated as fixtures. And then in my test, I have ops, context, and calling method. And so what PyTest does is says, runs the test, oh, but there's ops. Let me run this and return BPY ops. In this case, it's loading the test file. With context, it's running and importing the context. With calling method, it's running this and returning it. And with the params, it allows me to run the same test with different parameters. So instead of having a test of viewfrustum and a test for occlusion and a test for distance, I can have one test for all of them. Unit test doesn't have a native option for fixtures as far as I'm aware, but you can just use classic setup and teardown functions where before any of my tests, install the add-on, after all of my tests, disable them. Next is code coverage. And so code coverage is like if you're painting a wall, you want to make sure you're covering the entire wall, you're not missing any big spots. With code coverage, it's the same thing. You're making sure that the tests are covering all of your add-on code. And so with InView, I've been developing tests for a long time, so a lot of my files are covered at 90 or even 100%. If you're just starting with code coverage, I would say 50% is like a good bare minimum to start with. That's usually when tests kind of start feeling useful. And 70 to 80% is kind of a good general baseline to maintain. You could do more than that. You could go 90 or even 100% with your code coverage, but it can kind of feel like you're lying to yourself a little bit of, I have 100% code coverage, but that doesn't guarantee no bugs. It just means that your tests are covering everything. So it's only one way of measurement, so keep that in mind. Next, you can automate the automation. So we already had scripts for our tests, but we could have scripts run our scripts. And with the help of things like GitHub Actions, you can have your tests run every time you push changes to your code repository. Or if someone is contributing code and you want that review to automatically trigger the test to be run on their code. I initially planned on covering this, but when I talked to another presenter, Brady Johnston, he actually was planning on covering this with GitHub Action as examples. So instead, I'll defer to his presentation from BCON. It's called Extensions Are Coming, Rethinking Add-on Development by Unlocking Python's Full Potential. He has great examples in his presentation of GitHub Actions of building and testing and releasing your add-on. So highly recommend that. And here is the demo. So if you want to follow along, I'll have all these repositories freely available. And without anything else, let's just test and make sure that all of these are running. It runs all the tests. It's going to run the UI as part of that test as well. And this is just with Blender as a Python module, so that's how that's being tested in this case. But if you're interested in just running with the Blender executable, then you just run this command. Let me go over the repository really quick. So there is a basic add-on with the register and unregister functions, BLinfo up here, the extension manifest, then a Python file for the panel, as well as a select operator. And so this is using unit test for this example. And so in this, just a really simple test, just making sure that the Blender Python module is imported correctly. If this fails, then obviously something else is wrong. I also have a test config file, which will go over the BLinfo and the extension manifest and make sure that the info matches between them. Because sometimes I have the issue of updating the extension manifest version, but not the old BLinfo version. So having a test for this is just a good way of ensuring that parity between them and that you're not just forgetting to update a version at some point. Then we got our test add-on case. This is for installing an add-on, not as an add-on extension, but just as the old style add-on. And so when I talked about installation of testing installation, so I test installing the zip file and enabling it, and then I test disabling and re-enabling. So when the user is pressing the checkbox, that doesn't make any errors. Checking that the panel exists, kind of checking that those attributes or properties exist, and testing that the operator works. Again, you can just keep it simple initially. And then finally, a teardown class of, after all the other tests in here are run, disable the add-on, remove the zip file, and remove the installation of the add-on. There's also the installing of an add-on extension. And with that, you just need the parent folder of your add-on to act as an extension repository. So I have my add-on testing folder. I just need its parent folder to be an extension repository, and it'll pick up the add-on. And so then you do that and you just enable it. Do similar tests. With the add-on operator, I added some more thorough tests. I actually know some people didn't know this, but if you have an operator that has a collection property, so it's like multiple items or things like that, like you can test that. Like you can test passing multiple parameters. So with here, I just have objects to select. And then for my collection, I have one item here and one item here just as dictionaries, Python dictionaries. And then of course, after that, disabling the add-on. Now with the UI, it's a little bit interesting. So I run Blender. So I need the Blender executable in this case. So I run factory startup and add that event simulate flag. And I added a extra script to run the event simulation. So I tried to keep it very simple, but the important thing is that when you're doing event simulation, you need to use Blender's app timer. Like you can't just call event simulate multiple times. You have to use the timer to let kind of Blender process that event. And so with the script, I delete the default cube as per tradition. And so I have it just simulate closing the splash screen with the escape key. So this line, I press X to prompt deleting the cube, and I have it press enter to confirm the confirmation prompt that pops up and actually delete the cube. So let me show that really quick. I'll disable quitting Blender for this test, so that way you can see it happen. Let's rerun that. Run the UI. There you go. That's the fastest deletion of the default cube. Maybe not ever, but it is a very fast deletion. But Blender is deleting the default cube itself. And so let me show a slightly more thorough example with Light Painter. And so something I did in this case with testing both add-ons and add-on extensions, that you want to sometimes test the same things just for both cases. So what I did is I just made a base class of all these different tests. And then for my install add-on, I just inherited that class. And so up here, I just use the base class. So that way it utilizes the same tests for both installing the add-on and an add-on extension. It's probably a bit overkill, but I figured it was worth at least demonstrating how that works. But let me run this. And so this one I'll run with the Blender executable. And copy the commands just for convenience. Yes. Run that. And so you can see it's drawing for Light Painter and running through the different shortcuts, like with offset, lamp size, the power, and the axes. And so with that, thank you for watching. Thank you for listening. I wish I could have been there for Blender Conference, but I'd rather not get anyone sick. Again, I'll have all these links and code repositories freely available for you to review. If you had any questions, feel free to comment below. Thank you again. Happy testing and happy blending.